Welcome back, everyone. We are going to do something very different in this video lecture. We are gonna transition away from informal logic, and we are going to start to talk about logic in a formal sense, in a symbolic sense, even. And so we are going to jump into a sort of logic that is known as propositional logic. Propositional logic. And the reason why we are going to explore this topic is because it is going to help us be able to determine whether or not any deductive argument we come across is valid or invalid. You know, a lot of times you can tell just by reading the argument that it's no good. But sometimes you might suspect that there is something illogical going on. You might suspect that I don't think this conclusion follows from these premises, but you're not quite sure. So, what philosophers did over the centuries is develop a formal way, a systematic way to prove without, beyond a shadow of a doubt, that the argument in question really works, logically speaking, that it is valid, that the conclusion does in fact follow from the premises, or that it does not. And the technique that they developed begins with an artificial language. So all of you know at least one language, the language that you primarily speak. So for me, that's English. Some of you might speak multiple languages. Um, and those are all natural languages because they evolved and developed organically, naturally, with human beings socially over time. But there are some languages that are not natural, they are artificial, they are created by human beings for a specific function, and they are very Spartan, or can be, and serve a very specific purpose. So, for example, those of you who are studying or plan to study computer science, you have to learn all sorts of artificial languages, the language in which programming code is written. Those languages are not in English because computers don't really speak English. You know, their language, you know, at its bottom is still binary. It's still ones and zeros. And so we needed to invent a language to more easily, in a practical way, get computers to do what we want them to do in terms of ones and zeros without just having to just put a just zero. You know, if it gets quite tedious if that's what you have to do. But at the end of the day, it's binary. Okay, so let's get into our artificial language, which is the language of propositional logic. And so we've talked about arguments that are inductive and deductive arguments. So for the rest of the course, we are going to focus on the formal logic of deduction. When we looked at a lot of informal fallacies, we looked at arguments that were often inductive. And so now we're transitioning to focus on deduction. By the way, propositional logic is sometimes known as sentence logic or sentential logic. And that's because at the heart of this language, or at its heart, are propositions or sentences. So we talked a little bit about the distinction there. So for many logicians and many philosophers of language, there's a distinction between sentences and propositions. There's a difference between a sentence and its meaning. So, for instance, you could say that the house is white, or in another language, La casa está, or es blanca. He said that in his horrible Spanish accent. But so those are both sentences. One's in English, one's in Spanish. Those are both natural languages. So they're different sentences, and yet there's something similar or the same about them. Namely, they both mean the same thing. Well, that meaning, that precisely is the proposition, or sometimes we'll say statement, that is expressed by the sentence. So there's the sentences we use, and then there's the meaning expressed or behind those sentences. And those aren't one and the same thing. Just like a picture of something is different than the something that the picture is of, right? So, if you were to look at a picture of a mountain or a tree, you're not looking at an actual mountain or tree. You're looking at a representation, something that is supposed to visually express a mountain or a tree. Similarly, sentences are different than the things they express. And so, again, that's at the heart of what we're going to be doing here. Don't worry about this first part, syllogistic logic. Again, the fundamental at the heart of this system are propositions, or we're going to use these as synonyms, statements or propositions. Those are the meanings, or what is expressed by sentences. And again, this is sometimes called sentence logic or sentential logic, to put sentence into adjective form. How long would it take me, to teach you a natural language? It could take a long time. It could take years, maybe semesters, maybe months, maybe weeks. How quickly could you learn a foreign language? Well, I'm basically going to teach you a language in about an hour, and that's because it's a very Spartan, very very simple, intentionally simple language with very basic rules and very basic components, and that's intentional. So what's the point? Well, what logicians, again, those are people who are professional philosophers who study logic, instead of a magician, these are logicians, people that do magic, people that do logic. Sounds kind of similar. What logicians wanted to be able to do, their dream was to be able to express ordinary English sentences, any English sentence, at least the declarative ones that are meaningful. So we don't have to worry about questions and commands and exclamations. But at least for the meaningful declarative sentences, logicians wanted a simple language that could represent them in a very clear and basic way, really to be able to easily see the logical relationships within these sentences, or rather the propositions that are expressed by them, and also the relationship among those propositions. Because if an argument is to be valid, there has to be some relationship, when it comes to truth and falsity. I believe I said before, and if I haven't, this will be for the first time, that it can be helpful to think about validity in terms of truth preservation. And I explain this in terms of inputs and outputs. So if an argument is valid, if you input truth, if the premises are true, if we were to input truth into the premises, if you will, then the output will also be true. The conclusion, if you think of it as the output, that will also be true. So in this sense, valid arguments are truth preserving. If you start with truth, you will end up with truth. And so such that it would be impossible to end up with falsity if you are given truth. Hence the definition of validity that we've been working with. An argument is valid if and only if it's impossible for the conclusion to be false. It has to be true given true premises. Okay, So that was an overview, perhaps maybe a bit too technical and long-winded of an overview, but so be it. This is the way it goes. Uh, let's jump into the mechanics of this artificial language known as propositional logic. At in the most elemental or elementary sense, the basic unit or units of this language are simple statements or simple propositions. Other systems call these atomic sentences or atomic statements. So for instance, something simple like, so if I've kind of lost you in the first 5 minutes, here's where you can be like, I can rein it in and we can all get in on the same page. Take a very simple sentence. Ryan lives in California. We are simply going to symbolize that entire sentence or the statement expressed by that sentence with a capital letter. And so in this case, I chose C for California. I could have chosen R for Ryan. So simple statements or atomic statements, they are going to be symbolized with single capital English letters of our English alphabet, A through Z. How about this? The 49ers will win the Super Bowl. Well, that might be wishful thinking, but hey, it's happened before. So I need to pick a capital letter, and maybe I'll pick F for the 49ers. I could have picked S for Super Bowl or B for Super Bowl or, A or X or Z. So here are some more from Hurley, our author here. Fast foods tend to be unhealthy. How about capital U? James Joyce wrote Ulysses. That's true, actually. Very famous Irish author, I believe, wrote Ulysses. How about capital J? Parakeets are colorful birds. P. Bluefin tuna is threatened with extinction. B. Okay, so that's simple enough. And so now we're going to build off of that. If these are the basic building blocks, then we can use them to create more complicated sentences. That's why they're sometimes called atomic statements or atomic sentences, because we can make more complicated sentences, just like atoms are the basic building block of matter. If you take atoms and you put them together, you can create molecules and then even more complicated molecules out of that. And then out of a bunch of molecules, you can get a substance, or you can get something even more complicated. You can get a protein, right? You can get DNA. It can be broken down into the molecular and then the atomic level. And so we are going to do the same thing here. So we're going to take our basic atomic or simple statements, and if we add this symbol, the tilde symbol, which represents the property of negation, we can deal with negations or not statements. So I don't live in Alaska. Ryan, do not. That's a funny typo. That's better. Ryan does not live in Alaska. I'm sure. I think originally I had this as I do not live in Alaska, and then I put in my name. Ryan does not live in Alaska. So if you wanted, suppose you wanted to say that I do live in Alaska, that could be just capital A. But then to capture this not, we need a special symbol, and we're going to use this one. So if A is Ryan does live in Alaska, then not A, negation A, captures the meaning here that I don't live in Alaska. Maybe the 49ers will not win the Super Bowl. There are a bunch of other teams, so who's to say it'll be the 49ers? Not F. F here doesn't mean football or doesn't mean 49ers. It stands for the statement the 49ers will win the Super Bowl. And then to capture the not, we need this negation. So whenever you have a statement that is any more complicated than a simple statement, like these negations, there's an extra layer, extra symbol or complication to these statements. We no longer refer to them as simple. We are going to count them as compound. So just like we talked about atomic statements, you can group them together into more complicated things. You might get molecules, and that's why these are sometimes described as molecular statements. So by if you want to if you're asking, okay, well, give me a general definition of a compound statement. It's any statement that has what we'll call a connective or operator in this case. So far we've only learned about one connective, the negation, and there's going to be 4 more. Here's some more examples. Rolex does not make computers. Well, if R symbolizes they do make computers, then they do not make computers is not R. There are a couple other phrases in English that capture the meaning of this not. So these are 3 different ways of saying the same thing, or at least for our new artificial language of propositional logic, we will symbolize them in the same manner. And that is either because all 3 of these mean exactly the same thing, or they're not different enough. Or the difference, if there is a difference between these 3 sentences, our language isn't nuanced enough to capture it. And so we'll just treat them as all the same. But as we go through them, you might say, oh, these are just 3 different ways of saying the same thing. I might say as much. Rolex does not make computers. It is not the case that Rolex makes computers. I mean, these 2 statements certainly seem like 2 different ways of saying the same thing. It is false that Rolex makes computers. Now, a very, I don't know, technical linguists, you might say, well, these 2 are synonymous. This one is a bit different because we're not just talking about this is getting technical, but we're not just talking about syntax here. We're talking about semantics, because whenever you bring in the notion of truth or falsehood, you are talking about what linguists and philosophers count as semantics. But for our class, we'll just symbolize this as not R. So 3 different ways of saying the same thing. Rolex makes computers. R. Well, that's false. Then we can symbolize that by just using this negation symbol. Okay, so I hope that made sense. All right, let's go to our next connective. By the way, connective, operator, 2 different ways of saying same thing, at least for our class. The next one represents the and relationship. So, of course, these are conjunctions. For example, what if we wanted to say 2 things? Ryan lives in California and he doesn't live in Alaska. We could symbolize that as C and so here's our symbol for and. It's just a simple dot, not A. Now we need the negation because if we just had A here, this would symbolize that I do live in Alaska, but I want to capture that negation. Now, some of you might be wondering, why don't we just use plain old A without the negation? Let's just symbolize this as C and A, and let's have A be defined as Ryan does not live in Alaska. So there's a couple of reasons why you can't, or at least shouldn't, do that. Number 1, this statement has the negation element embedded in it, And if you symbolize this merely as A, you are not telling whoever is reading this that there is a negation element here. And so it's not that your symbolization is wrong. It's just, it could be much more specific. There's information that you could convey that you are not. So there's a couple reasons. Another one is, we're just going to specify that if a statement is negated, you must use the negation symbol. You're not allowed to capture a negation with a capital letter. So we're just going to build that into our system as a rule. And then thirdly, there's a slippery slope argument that we could make. It's, if you are allowed to symbolize this negation with just an A, then why don't I just take this whole conjunction and symbolize it with one C and just say capital C symbolizes this whole statement, this whole and statement. And again, it's not that that's necessarily wrong. It's just that you could be much more specific. You could tell your reader or your listener much more about the sentence, and you are doing them a disservice because you're not being explicit about all that's going on in the sentence. And there are a couple things going on. Namely, there's a conjunction, and the right part of this conjunction is a negation. So you want to do it this way. By the way, in other systems, an ampersand is used that has the same meaning as the dot. And also this sort of upside down looking V symbol, which has several names. One of them is a caret. And so our textbook, our author uses the dot, but other books that where you could learn about, if I use a different book for this class, in fact, the one that I used to use, that textbook uses the ampersand for the and. And so I will give you freedom. If you want to use the ampersand, it's easier to type, if you're on a computer, go ahead and just, I know that the dot or the ampersand represents conjunctions, represents and. If you want to use this, that's fine too. I don't mind. And I don't, let me annotate here. This is another alternative symbol for the negation. So a negation symbol looks just like a line with a little serif there, a little kind of down part. And so if you want to represent negation with that, that doesn't bother me. Go for it. Okay, good. The Rams will win the Super Bowl, and the 49ers won't. R and not F. So R means the Rams will win the Super Bowl. F means the 49ers will win, but we want to say that they won't. And so we put in the negation here, and then this and that gets captured with the dot. So the Rams will win the Super Bowl. All of that is R. The 49ers will win the Super Bowl is F, but then to capture this negation, that not, that's in the contraction there, we're going to put the negation symbol. And then this and, we are going to symbolize with the dot. And so that's how you get R and not F. Cool. Oh, yeah. Technically, the conjunctions have two parts, the left part and the right part. And naturally, we call them conjuncts. So the left part of this and statement is R, that's the left conjunct, and the right conjunct is not F. Some examples from the textbook. If you want to symbolize Tiffany sells jewelry, and Gucci sells cologne, you could do T and G. So T for Tiffany sells jewelry, the dot for and G for Gucci sells cologne. Now, this is interesting. This sentence really means the same thing. Tiffany sells jewelry, but Gucci sells cologne. Because we're still saying that two things are true. Tiffany sells jewelry, and we're also stating that Gucci sells cologne. So we have the T and we have the G. So oftentimes, but will be symbolized just like and. Maybe not always, but often. So practice makes perfect, and the more you do of these, the more you'll get a sense of when you want to symbolize the dot, or symbolize the word but with the dot. Now, again, there might be some connotation, something that is implied by this but. You know, some negativity almost. You know, like I graded your exams, but you might not like the results. You know, so the there's what I'm explicitly saying, and then there's what I am connoting or implying. And it turns out that English, it's much more complicated and much more nuanced than our very Spartan and basic artificial language of propositional logic. And that's okay. We want our symbolization to capture a lot. Does it have to capture everything? Well, even if it doesn't, it can still be a very powerful tool, and that's what matters. Here, we're saying two things. Tiffany sells jewelry, however, Gucci sells cologne. Again, we're saying both of these are the case, and so that's why we're going to use the dot here for however. Tiffany, and so sometimes Tiffany and Ben Bridge sell jewelry. So some of you might be familiar with this store, this company, Ben Bridge. You know, Tiffany is maybe more famous jeweler. So this is a shorter way of saying Tiffany sells jewelry and Ben Bridge sells jewelry, which would be symbolized this way. And this is we've just said the same thing, but we've shortened it. So there's lots, here's 4 different ways of expressing a conjunction. And, but, however, and then we have and again, but kind of this abbreviated sense, because the T here, it does not stand for Tiffany. So I trick students all the time. So I might say, okay, here's our symbolization, T and B. What does T stand for? And then students say, oh, it stands for Tiffany. No. Capital letters in our system represent simple statements. So it has to represent an entire statement. Tiffany is not a statement. Tiffany is a thing. It's a proper noun. It's a company. Tiffany sells jewelry. Now that's a statement, right? You need to have a subject and a predicate for it to be a complete sentence, for it to express a statement. And Tiffany by itself doesn't do that. Okay, hopefully this is all making sense. I hope it does. Again, in this part of the class, it can get very symbolic and almost can have the feel of sort of a quantitative or mathematics class. And that makes sense because there's a lot of overlap between logic and mathematics and computer science even. And once you get theoretical enough, it becomes less and less clear what is at the bottom of logic and mathematics. So if you ask some logicians, they'll say, at its bottom, at its most fundamental foundation, mathematics is logic or is rooted in logic. And then you might hear the reverse from some mathematicians. Oh, logic is just basically abstract mathematical analysis or thinking or something. And so maybe they merge and they're the same thing. And also to that point, many people are we all have the ability to do logic. You're a human being. You are rational, at least to a certain extent. You're logical to a certain extent. And some of you, it's just the way that you're hardwired, or, maybe there's a sociological factor that you just kind of naturally are good at thinking in this way and are good at doing this sort of activity, so you might be drawn toward things that really engage that part of your psychology or that part of your mind, so if you like doing a Sudoku or crossword puzzles or logic puzzles, great. And you might also do really well in your math classes. And then other people who, this might not be their strength. But the good news is everyone can do it. Maybe some people, they pick it up really fast. Some people, it takes a little bit of time. But the good news is that we have the whole semester, right? So you have plenty of time to figure this out. And practice makes perfect. And so some of this will click more once we start doing the exercises. Okay. Next up, we have disjunctions. So we've done simple statements, and now we're doing compound statements or complex or molecular statements, and we've done negations and then conjunctions, and now we're going to do disjunctions, which are or statements. So let's say you wanted to symbolize Ryan lives in California or he lives in Alaska. Well, we could do C, and then this symbol, the symbol for or, sometimes it's called vel, and I'll just usually read it as or, C or A. Again, what does C stand for? You might be thinking, oh, California. No. It stands for Ryan lives in California. What does A stand for? Oh, Alaska. No, Ryan lives in Alaska. So C or A stands for I live in California or I live in Alaska. How about this one? George hates raisins or prunes. It could be R or P. So R stands for raisins? No. George hates raisins. P stands for prunes? No. P stands for George hates prunes. And again, this sentence is a shorthand way of the longer or statement, which is represented here. The longer or statement is George hates raisins or George hates prunes. We just have shorthand sometimes in English, and that's to avoid repetition. Like pronouns serve the same function. If you're writing a letter about someone, if you're describing someone, Ryan has done X, Y, and Z, you don't want to just repeat Ryan every sentence or every other sentence, and so we'll use he. Oh yeah, this symbol is also called the wedge, and so I'll read it as or I'll read it as wedge, and instead of separating two conjuncts like in a and statement, a conjunction, it delimitates. It sits in between two disjuncts, the left and the right disjunct. So I might say that sometimes. Here are some more disjunctions. Aspen allowed snowboards or Telluride does. A, wedge T, or A or T. And these are three other ways of saying the same thing. In this version, we have the word either in front of this same first sentence. And this is just how English works. Sometimes we include the either, and sometimes we just drop it. We will notice, or we will see the same thing with if-then statements, which we will call conditionals. So for instance, let's do this one here. If today is January 31st, then tomorrow is February. Sometimes in English, we drop the then. You might just say, today is January 31st, tomorrow is February. That's the same meaning. And this is just how our organic language works. So these with the either, without the either, doesn't change the meaning, and it certainly doesn't change how we would symbolize it in propositional logic, A or T. Unless, oh boy, this unless is a can of worms. Not always, but often you can capture the meaning of unless with the wedge. So the default is, well, you can always express unless with wedges. I'll say it that way, but sometimes you might need more than one. So in this case, we can get away with just using one. So often, unless is just another way of expressing a disjunction. Aspen allows snowboards, or Telluride does. I'm going to say a lot more about unless later. So for now, just take my word for it that often it's just another way to express the wedge. And in English, sometimes we move clauses around in a sentence, and that doesn't change the meaning, right? So we're just taking this clause, and if we put it at the beginning of the sentence, we end up with this sentence. It means the same thing. Again, we often do this with conditional statements. So where is it? Here, let's clear all these drawings. Here, I could take this if clause and I could move it to the end of the sentence if I wanted, and it would mean the same thing. What would that look like? Tomorrow is February, comma, if today is January 31st, and then the then goes away. And that's just the way our language works. All right, so just like we had different ways of expressing an and relationship, we also have a multitude of ways of expressing or statements. Oh, let's see, did I say about... Oh, yeah, okay, we're here. Inclusive and exclusive or. Remember, in an earlier lecture, we talked about ambiguity. Like the word hot is semantically ambiguous. If you say that the dish or the meal in front of you is hot, it might be unclear. Are you saying that the food is spicy, or are you saying that it is hot temperature-wise? Like I might burn the roof of my mouth if I eat it, or maybe you're saying it's both. So just like the word hot is ambiguous, or is also ambiguous. Sometimes we mean this or that, and sometimes we mean this or that and not both. And not both. So for instance, George hates raisins or prunes. Presumably, it's possible he hates both of them. Ryan lives in California or lives in Alaska. It's possible I live in both, right? I mean, not full time at both, but maybe I have a second home in Alaska and I live there for half the year. An easy example where the or is obviously inclusive is, imagine if where you live, imagine you live on the corner, like on the intersection, let's say you live on the corner of First Street and Main. First Street and Main. So do you live on Main Street? Yes. Do you live on First Street? Yes, you live on both. And so let's say I was trying to give directions and I forgot. I was like, oh, I know you live on the corner, but I forget what it. Uh, I don't know. You live on First Street or Main or something, and I can't remember. It's one of those. It's First Street or Main, or both. Right? That's a possibility. Sometimes we use or in an exclusive sense. I mean, the classic example is super salad. So at many sit-down restaurants, the server asks you, "Oh, super salad comes with your entree. Which would you prefer?" And if you say, "Oh, I want both," they might say, "Oh, that's not how we do it. You have to pay extra if you want both. But without paying extra, you have to pick one or the other. So you can have soup or you can have salad." So we could have S for you can order soup or you can order salad. Now you might be tempted, "Oh, I'm going to use S again." And you might say, "This S represents," again, it can't just be soup. "This represents you're going to order soup." And you might say, "And this one represents you're going to order salad." But our artificial language, you're not allowed to do that because, you would have, if you don't specify that this, you got to tell me that this one's different. And we don't really have a way to do that. I mean, maybe if you put like a little subscript or something, you need to have S1 and S2. And so this S2 is different. But that gets overly complicated. And so just use a different letter, right? You got 25 other ones. So how about this? A for, we used up S. So what's the next letter in salad? I'm going to go to A. So you can have soup or you can have salad. And then to represent the exclusive nature of this or, you're going to put this in parentheses. You're going to say you can have soup or you can have salad, and you can't, so we'll use the negation here, you can't have both. So we've learned about conjunctions. So this S and A is the conjunction. You can have soup and you can have salad, but you can't. We're saying no to that conjunction. And we've introduced something new that we haven't seen before, parentheses. So parentheses are a part of our artificial language. So far, we have capital letters that represent simple statements, simple propositions, atomic statements, A, B, C, D, all the way to Z. I'm going to put braces here. This represents a set of things that make up our language of propositional logic. And I'm going to put a semicolon here. And we've learned about, let's see, the first symbol we learned about is the negation, right? So that's a connective. And we've got another connective, the and. These are all semicolons, not little j's. And we have wedges. And we're also going to add left and right parentheses. And there's going to be a few more things. So I'm going to put ellipses here and I close a little brace here. So this represents a set. So far, these are all the things that we can use as a part of our language. And it's pretty powerful. We're not going to add too many more things to this. Just a few more connectives and we'll be done. So the parentheses, they're meant to group things together. And you can see why we need them, because if we didn't have these parentheses, then this negation, it would only negate the S. And then you would be saying, you're not going to order soup and you're going to order salad. No, but that's not what we want to say. We want to say, you can't order both. And so to get that, we need the parentheses. This will become more natural with practice. So again, you can have soup or salad, and we're going to group that together. Oh, and by the way, you can't have both soup or salad and not both. That is exclusive or. And here's another example of exclusive or. The Rams or the Bengals. So this is 20, let's see. Yeah, this was like February of 2022, this Super Bowl. The Rams or the Bengals will win the Super Bowl. They were playing each other in Los Angeles. So you might say, oh, that's RB. The Rams will win or the Bengals will win. But we know that it's impossible for both teams to win because that's the nature of the Super Bowl. You play until there's a winner. No ties are allowed, and you can't have co-winners. So this is an example of exclusive or. We're excluding the possibility of both. Rams will win or the Bengals. Oh, and by the way, it can't be both. So so you might be thinking, oh, well then for the other kind of or, which is inclusive, right? So instead of exclusive, we have inclusive here. So in and then inclusive. You might say, oh, well then don't we have to say something like, going back to the, how about just flavors of ice cream? We have Rocky Road or we have vanilla. You can have Rocky Road, you can have vanilla. And what if you say, can I have both? Sure. So you might say, well, don't I need to say you can have Rocky Road or vanilla, and you can have Rocky Road and vanilla. Well, first of all, this is not saying what you think it is saying. This is saying you will have Rocky Road and vanilla, and you will have Rocky Road or vanilla, but that's not quite right. So for now, just take my word for it, and we'll explain further once we get once we get deeper into learning about this language. For now, if the or is inclusive, all you need is just a single wedge. You don't need to say and possibly both. I won't say exactly why now, but just take my word for it. Okay, so to recap, with or statements, let me clear all this. We got a bunch of mess here. For or statements, which are disjunctions, you're going to use the wedge. If it is not clear whether it is inclusive or exclusive, then sometimes if we don't know what is meant, then we might not know how to symbolize it, and that will happen sometimes. Remember, we said one area of philosophy is epistemology, so we might just have not a logic problem, not a symbolization problem, but a knowledge problem. We just don't know what you mean. There's an ambiguity there. But the wedge, it's by definition, it's inclusive. It's inclusive. So that's why you don't need to add the other part, possibility of both. It's just built into the symbol. So just ask yourself, is the possibility of both excluded? And in these first two examples, it's not. And so we don't need that extra bit. But then once we get to something like this, the possibility of both is excluded. Rams will win or the Bengals, but not both. And so that's when we need to add this extra bit. If you're following along, great. If you're not, don't worry about it. That's kind of where I would expect you to be. And once we practice more, then I think it'll click. All right, let's continue on. We have not both, which we've really already done. We've done not both because we learned about exclusive or. So the second part of exclusive or is not both. And then there's something that often sounds similar and students get mixed up with not both: statements that contain neither nor. Okay, and then this rule that I'll talk about, De Morgan's rule. Don't worry about that for a second. Let's just go through some more simple examples. Again, that's my favorite way to explain things. Both Romeo and Juliet are coming to the party. Well, that's a conjunction. That's an and statement. So we're going to use a dot. That's going to be R and J. R represents Romeo, right? Wrong. R stands for Romeo is coming to the party. I got you there for a second. J stands for Juliet is coming to the party. And then we put this dot here to represent the and. They're both coming. What if we wanted to symbolize this statement? Romeo and Juliet are not both coming to the party. They're not both coming. Well, there's two ways to symbolize it, or these two ways work. All you do is you take your both statements, you put it in parentheses, and you add a negation. Romeo and Juliet are not both coming. So what we're saying is, we're saying something very weak, actually. Suppose this is true. Romeo and Juliet are not both coming to the party. Do we know if Romeo is coming? We don't know. Do we know if Juliet is coming? We don't know. Is there a chance that neither of them will show up? Maybe. We don't know. Well, what do you know? Well, all we know is there's no way that they're both going to show up. They're not both coming. That's what this sentence means. And this is how you symbolize it. It's pretty easy. You just take the and statement, slap parentheses around it, and then add a negation. Forget about this part and this part here just for a second. Let's go to this third one. Neither Romeo, you guys say neither or neither? Tomato, tomato. I kind of vacillate between both myself, which is kind of schizophrenic, but oh well. So I'll do it right now. Neither Romeo nor Juliet are coming to the party. So what you're saying there is Romeo's not coming, Juliet's not coming. Neither of them are coming. And so probably the most straightforward way of saying that is Romeo's not coming and Juliet's not coming. That's one way to capture this. The other way is to negate the wedge. So in parentheses here, we have Romeo or Juliet is coming. And then what you're saying is that's false. It's false that either of them are coming. It's not the case that either one of them is going to come. That's what this says. And that's just another way of saying this. Okay, now to De Morgan's rule, or De Morgan's theorem, it's sometimes called. Some of you might remember from mathematics that there is, that was a bad arrow. Drawing the trackpad here, so it's not very precise. Some of you might remember from mathematics when it comes to, I don't know, multiplying something like this. 3 times the quantity of x plus 2. You might remember this from algebra. That the way that we multiply this out is we sort of distribute the multiplication of this 3 to each of the components of this sum here. And we end up getting 3x, right? 3 times, there's an invisible 1 here, right? So it's 3 times 1, which is 3. The x comes down. And then 3 times 2, which is 6. And then this plus comes down. And so we can, I caution you. So mentally, I do think of this in a similar way. So this negation sort of gets distributed to the R and the J. But the difference between these two operations, there's some similarity, but they're certainly not perfectly similar. Is in this one, the operator, the plus sign, the addition, that doesn't change. However, when you do this in propositional logic, you have to change the and to an or. And if you don't, if you kept this a dot, it would be incorrect. So similarly here, we can take this negation and, if you will, distribute it, for lack of a better word, to the R and the J. But in this case, we have to change the wedge to the dot, change the disjunction to a conjunction. So the way De Morgan's rule works in general is that if you have a negated and statement, so let's just say in general A and B, right? So in this case, we're replacing A and B with Romeo is coming to the party and Juliet's coming to the party. Then that is logically equivalent to, that's what these four dots mean. That's logically equivalent to not A or not B. And similarly, oh, and by the way, this goes in two different directions. So you could start with this and convert it, if you will, back into this, and that's perfectly acceptable. So these are two different ways of saying the same thing, and these are two different ways of saying the same thing. Similarly, if you have a negated wedge statement, and this time, just to show you I can do it, I'm going to use different, these are called meta variables because they're variables for variables. Like one, it's like Inception, and it's like, or like it's meta. It's a dream within a dream. We're doing variables of variables, and so we're going to lowercase letters instead of uppercase letters. Don't worry about that too much, but instead of something and something, call it A and B. We'll do something and something. We'll call it P and Q. Philosophers love. You know how in algebra you see a lot of A, B, and C. You know, like A squared plus B squared equals C squared. Or you see like a lot of X, Y, and Z. X squared plus Y squared equals Z squared. In logic, you see a lot of P's and Q's and R's for reasons I won't go into. Okay, and then we're going to use these four dots again. That is logically equivalent to not P. And then this dot has to become a wedge or not Q. Yeah, so this is actually a rule of substitution or a rule of replacement that we're going to learn later. We're going to learn a bunch of these rules. This one's called De Morgan's rule, named after a famous logician whose last name was, you guessed it, De Morgan. So I hope that makes sense. Let's see here. I want to stop. All right, we're going to power through a little bit. I mean, you can always, pause at any time and take a break, but I think we can do it. Let's power through. All right, our second to last connective or operator represents the if-then relationship, the conditional relationship. Example, if Stanford mandates masks on campus, this is kind of during the COVID era, comma, then UC Berkeley will mandate masks on campus. So maybe campuses are kind of looking at what the other ones are doing. So we are going to represent this if-then relationship with this symbol, which is called the horseshoe. And this left part, this left part, let me change my color. I'm tired of green. Let's go with blue. This left part here, this is the condition part of the conditional. You can think of it this way. If you meet this condition, that's why it has the if, then this will be the result or the consequences. If this happens, then this will happen. If this, then that. The name for this condition, more formal name, is the antecedent. So you can see there's some Latin root here, ante, which means before. Like in poker, you need to ante, and it's spelled this way, and that's, you got to put in your initial bet before the rest of the hand is played out. Often the rules in poker. And then this right part is the results of this condition, this antecedent being met, the consequent. How about in this case? We talked about this. Today is January 31st. So we're not, the J captures this atomic or simple statement. Today is January 31st. And you might say, this is weird. It's like the then gets this symbol, the horseshoe, and the if, why isn't there like a symbol here? Well, we could have created a system like that, but logicians just decided we're just going to let this horseshoe capture this if-then relationship. And that's just what they decided. And so the F here, it doesn't just stand for February. It doesn't stand for then tomorrow is February. It stands for the simple statement, tomorrow is February. Do you guys say February or February? It's another neither situation. Both are acceptable, I believe. Conditionals are unidirectional. So just because you can think of it as streets. This is a one-way street. Just because the street goes this way, that doesn't mean that it also goes this way. It might, but not necessarily. So in this case, it certainly doesn't. If today is January 31st, then tomorrow is February. You can't reverse that. If tomorrow is February, think about this. If tomorrow is February, then, let's see, does this work? Wait, I may have misspoke. Well, okay, let's just think about it. Okay, if tomorrow is February, then today is January 31st. So that does work. I misspoke. So this happens to be a two-way street. But this one needn't be, right? If Stanford mandates mass, then Berkeley will mandate mass. But maybe it doesn't go the other direction. Let's say UC Berkeley mandates them first. Maybe Stanford, maybe Berkeley's more of the follower and Stanford isn't. An even more straightforward example, how about this? If it's a circle, then it's a shape. How might we symbolize that? Well, how about C, horseshoe? By the way, speaking of arrows, the arrow is an alternate symbol for the horseshoe. So if you want to use the arrow, which is a little bit easier on keyboards, that's fine. It's another way of expressing this. If it's a circle, then it's a shape, the S. So that's this direction. But the other way is not the case. If something is a shape, then it's a circle. No, what if the shape is a square or triangle or a hexagon? So the conditional, it's open. It's like a street where you definitely can drive one way. Can you drive the other way? Maybe, but maybe not. We're like open to that possibility, but it might not be the case. just like there are lots of ways to express conjunctions, disjunctions, lots of ways to express this if-then relationship. Oh yeah, here it is also symboled with the arrow. If Purdue raises tuition, then so does Notre Dame. P, so a lot of times I'll just read this as then. P, then N, or I'll read it as P horseshoe N. P, what does that stand for? Purdue, right? No, it has to stand for a statement that is what is expressed by a complete declarative sentence. In this case, Purdue raises tuition. What does N stand for? Notre Dame? No, it stands for Notre Dame raises tuition. And I said we can, some of these in English, we can move clauses around without changing the meaning. So what if we take this if and we end with that? Then we'll end up with this statement. Notre Dame raises tuition if Purdue does. Means the same thing. The condition is still Purdue raising tuition, and that's why it's the antecedent. Purdue raises tuition only if Notre Dame does. So here we have this phrase only if. In the first two sentences, we just had if, there was no only. But it turns out in general, if you have a only if, oh, this is taking too long. Text. A only if B, that's going to be let's try again. In general, if you have A, and A represents some sentence or some statement in propositional logic that is legit, A only if, that will be A or should be. Now I need to go back to drawing. Yeah, in general, that's what you'll get. And so that's what we have here. Something only if something. Whatever is on the left will be the antecedent. And you might be thinking, why? I mean, I get that you are telling me that's the case, but why is that the case? That's what you might be thinking of. Well, think of another example. I don't know. Remember we did circle, let's do square. It's a square only if it's a shape. Just think about whether or not this is true, if this is correct. Just think about this. It's a square only if it's a shape. You know, you could, maybe to help you understand this, get rid of the only for a second. It's a square if it's a shape. That's certainly not right, because if we move the if clause to the front, that says if it's a shape, then it's a square. No, we don't know if it's a square for sure. Okay, so that's without the only, but you add that one word only, it changes the meaning. It actually changes the direction of the street, believe it or not. The square only if it's a shape. So when you say only if, what follows the only if is the requirement, right? Only if this condition is met, do you get this thing, right? And that's right? Being a shape, it's a requirement of a square, right? It's a square only if it's a shape. You know, if you don't meet the, if it's not a shape, then it can't be a square, in other words. So that's why this always works. Provided that is another way of talking about the antecedent. It's another way of saying if, right? We could have said Notre Dame raises tuition provided that Purdue does. So that's that phrase that captures the condition, the if clause. So that is like the second one. By the way, in general, if you have A if B, you're gonna end up with B horseshoe A. So with only if, between the A and the B, the order, if you will, stays the same. But if you don't have that only, if you just have A of B, the order is swapped. And it makes sense because what follows the if is the condition, is the antecedent. What follows the only if is the requirement. It's what's necessary. And as we will see eventually in the next slide, the necessary condition, that's always going to be the consequent. On the condition that, of course, that represents the condition. There's the word condition. That's another way of saying if. And so this is going to have the same symbolization. Implies that. That represents the horseshoe. Brown's cutting enrollment implies the following will happen and implies these consequences. Cornell does. Does C represent Cornell? No. Does it represent Cornell does what? Cornell cuts enrollment? Yes. Yeah, so lots of ways of expressing this conditional relationship. One more way is with mention of necessary and sufficient conditions. And so before I go into this mnemonic device of remember sun and this S horseshoe N, let's do examples. And this is from the first chapter. And so they could have moved this section or subsection in chapter 1 to this chapter 6, or they could have included a subsequent section that talks about this. And they don't have the exercises, but they talk about it a little bit, or they might reference it. I remember correctly. Let's go through some of these examples and just see if we can intuitively insert necessary, sufficient. Being a tiger is a blank condition for being an animal. So these are our options: necessary, sufficient, and then sometimes we want both. We want to say it's a necessary and sufficient condition. If it's a necessary condition, it's a requirement. It's a requirement. A necessary condition is something that you need, something that's required in order for the other thing to be the case. If you meet a sufficient condition, then you're guaranteed to be the other thing, or you're guaranteed to meet the other part or meet the necessary condition. So it's enough. It might even be more than enough, but it's enough. You've done enough to get to where you want to go, if you will. Okay, let's try this out. So being a tiger, is that a requirement for being an animal? Is being a tiger a requirement? If you're going to be an animal, are you required to be a tiger? No, humans are animals. Dogs are animals. So being a tiger can't be a requirement, but it's enough. If you're a tiger, that's enough to count as an animal. So it's a sufficient condition. So sufficient would go here. So I'll put S for sufficient condition. And the way that we would, let me go through these two more examples, then we'll talk about how to symbolize it. Being an animal is a blank condition for being a tiger. So this is the reverse. So is being an animal, is that enough? Is that going to guarantee, is being an animal going to guarantee you're a tiger? So you're an animal, so you have to be a tiger? No. So if we put an S here, that wouldn't make sense. So we don't want that. So instead, we want to say it's a necessary condition. Being an animal is a requirement. It's needed if you're going to be a tiger. You have to be an animal if you're going to be a tiger. Drinking a glass of water is a blank condition for quenching one's thirst. Well, is this a requirement? To quench one's thirst, do you have to drink a glass of water? No, you could drink a glass of another kind of fluid, right? You might say, well, it has to contain water. Well, now we get into the semantics of what Like is a glass of grape juice, is that a glass of water? Well, you might say, well, it's a glass of water and a little bit of something else. And then this will be interesting. Is there, and it also might be, this is where we'd have to ask a chemist or a physician or a biologist. Is there something you could drink that has no water in it and it would quench your thirst? And there might be some strange cases of thing. I remember when I was a kid, we'd go to these sporting goods stores and there would be this gum that was called like Sport Quencher or something. And like you would chew it and it would make your mouth water, and so like, does that psychologically trick your brain into thinking that your thirst is quenched? And then that's a good question is, what does it mean? So, we're getting philosophical in this class. What does it mean to have your thirst quenched? Is it the experience of it being quenched, or does it have to be quenched in a more objective sense? Like your body's actually getting fluids. But you can see what they mean here. It doesn't have to be water, presumably. It could be juice. It could be coffee. It could be milk, whatever. And so it's not a requirement, but that would suffice. That's enough. If you drink a glass of water, you know what? And yeah, I would say that they're looking for S here, or the answer is just neither. Because what if you've been in the desert for like a week and you are on the brink of dying of thirst and you drink a glass of water? You might say, my thirst is not quenched. I need a lot more. So maybe not even this is sufficient. So maybe the answer is neither. All right, how would we symbolize these? Well, remember the sun, right? I should have drawn this in yellow, but whatever. Just one thing to remember, sun looks like this, right? So if you imagine the U kind of turning 90 degrees into the horseshoe, if you remember this, you can never go wrong. The sufficient condition goes on the left. It's the antecedent. And the necessary condition will be the consequent, goes on the right. So being a tiger is a sufficient condition for being an animal. Okay, so the tiger is a sufficient condition. So tiger will go on the antecedent. So T for, now this gets a little bit weird. Like, what is the proposition here? Being a tiger is arguably not a proposition. So it would have to, there's something left unsaid here that I think is implied, something being a tiger. That's a statement. So if something is a tiger, maybe that's what we could say T is, then that something is an animal. Being a tiger is sufficient condition for being an animal. In other words, if you're a tiger, you're an animal. Yeah. Being an animal is a necessary condition. Okay, so necessary condition, that's going to go on the right, the consequent. So what is the necessary condition? Being an animal. Okay. And then what's left, something is a tiger, that's going to go here. So, hey, check this out. These two statements are two different ways of saying the same thing. Isn't that cool? Well, you might say, well, it's a little bit neat. I don't know if it's cool. Like, let's not get too excited about what's cool here. All right. And then drinking a glass of water, either we say we can't really express this with the conditional, or, if we want to say, well, yeah, come on, your thirst will be quenched to some degree. So we want the S. And so the drinking a glass of water, that's going to go as the antecedent. So let's say D for you drank a glass of water. And then thirst is quenched. I don't know, Q. Why not? And then again, we want a statement. So thirst is quenched. We need thirst is quenched. Yeah, I mean, that might be fine. But, you might say, then the person's thirst is quenched or something. Maybe just will work a little bit better. All right, cool. Hopefully this is clicking. I want to do a few more. This is kind of fun with this necessary sufficient condition. Having a racket. Is that enough to play tennis? No, you need other things. You need a court, you need a net. So it's not going to be sufficient. But presumably you got to have a racket or you can't play tennis, and then, there's a little bit of things open for debate, like, well, what if, can we play tennis kind of like with our hand as a paddle, or if you used, a makeshift racket, like you have a giant, smartphones are getting so giant, you kind of use that as like almost like an iPad or something, tablet. That's your racket. Is that a racket? Are you playing tennis? This is why we covered that section on definitions. And so, and we started with empirical questions, non-empirical questions, philosophical questions, things. This is one of the reasons why we talk to each other, right? Because we got to figure things out. The world can be complicated, and that's just the way it is. Heating water. Well, if there's a way to brew coffee without heating water, then this wouldn't be a necessary condition. It's certainly not sufficient, right? If you just heat water to get coffee, that'd be kind of cool, right? You microwave some, it's like a magical microwave. You microwave some water and then you open up and there's coffee. If that could work, then you could put S here for sufficient. I think they're getting at this is a requirement. Cold brew. You hear about cold brew. So if that's right, then it would be neither. Stepping on a cat's tail, is that the only way to make a cat yell? Is that a requirement for making a cat yell? No, absolutely not, right? If you yelled at a cat, if you threw something, gosh forbid, threw something at a cat, it might yell. So it's definitely not necessary. You can see they're going for sufficient here. And again, I don't even know if this is strictly right because, what if your cat is just super chill? Or maybe like enjoys its tail being stepped on, so it meows when you step on it. So strictly speaking, I don't think we get S either, but you can get the idea that this will do it. Usually do it. We talked about induction and deduction here, and if we kind of open up our interpretation of sufficient and necessary to an inductive interpretation, then we're cooking with gas here, because you could say, stepping on a cat's tail, it's likely enough to make it yell, inductively. It's inductively sufficient, that we could make that a thing. That'd be interesting. Burning leaves. That's certainly not a requirement, right? You could, take fire and burn all sorts of things, and you could get smoke. So it's not going to be a requirement, but that's one of the ways. It's a way to produce smoke. And then again, you got to be careful. I'm sure there's a way to burn leaves without producing smoke. Again, I don't know for sure, but I'm sure if you gave someone $1 million, like, hey, if you can burn these leaves without producing any smoke, someone might figure it out. But you can get like kind of, we can at least rule this out, right? Paying attention. Again, you can see, it's not going to be sufficient, because what if the lecture is in a language you don't understand, right? Let's say the lecture is in Mandarin, right? I don't understand Mandarin, and so I could pay attention all I want, and that's not going to be enough to understand, is it? So it's not going to be S. You could see they're kind of going for necessary here. Like, if you're going to understand, this is a requirement, you got to pay attention. I think this is pretty good, but is it logically possible to understand a lecture without paying attention? Sure. I don't know. What if it's like a super smart genius person, and they're kind of on their phone, they're talking with someone, they're kind of half asleep. And then it's like, what does it mean to pay attention, right? Well, it's like, don't they have like one, they're paying some attention? Does this mean paying all of your attention? There's some vagueness here. To what degree are we talking about attention? But you can say like, this is a requirement. It's not sufficient though. Being exactly divisible by 4 is a condition for a number being even. So this is a great example because here we can put in a definitive N or S. So why don't you pause the lecture and try to figure out, is this N or S? Okay. So think about N for a second. This isn't going to work because there are lots of things that are not divisible by 4 or, being, exactly. I'm glad they put the word exactly in there because that might change things. So like 10 is not exactly divisible by 4, right? You get a fraction if you don't get a whole number. If you 10 divided by 4, right? That would be 5 over 2, right? That's not exactly divisible. And yet 10 is even, of course. So necessary is not going to work. But we're going to get a rock solid S here because if something is exactly divisible by 4, then that number has to be even. And so we could do a mathematical proof to show this. So we're going to get a rock solid S. So why don't we symbolize this one? So S, that's going to go on the left. So being exactly divisible by 4. So why don't we say F? Don't say D. Being exactly divisible by 4. If it's exactly divisible by 4, then that number will be even. So that's how we would symbolize that one. So that's good. Yeah, I mean, try to think of a counterexample. 40 is exactly divisible by 4. That's even. 4 is exactly divisible by 4. That's even. 8 is exactly divisible by 4. That's even. So you won't be able to come up with a counterexample. So that's going to be rock solid. And we're noticing the difference between like the empirical world, the scientific world, and the mathematical worlds. The empirical world, deductively necessary and sufficient, it's not going to work so well. Maybe if we're dealing with like natural kinds, like a tiger, an animal or something. But even there, people might have some philosophical issues, but we don't have to worry about that. But once we get to mathematics, we get deductive certainty. And then finally, intending to deceive someone is a condition for telling a lie. I mean, that's the definition of a lie. So you can pause again if you want. Try to figure it out. Let's try N. So is it a requirement? Must you intend to deceive someone to tell a lie? I think so. I mean, if you're a little bit fast and loose with lie, sometimes there's the term lie and there's the term falsehood. And I think in politics and the news, a lot of times those are used interchangeably. But I think if you get a bit more precise and more technical, telling a falsehood, you could do it on accident, right? So if I, said today was the 20th and it's the 21st, like, did I lie? Well, I mean, that's kind of a loose definition of lie. I said something incorrect. What I said was false. I told a falsehood. So I think this is just a good, talk about definitions by difference and genus for telling a lie. And so when you have a definition like that, we're going to have N. And then because we have a definition that is complete in a sense, we're also going to have S. So if you intend to deceive, well, actually, no, I take it back. Because you need the outcome as well. This is like attempted murder versus murder. There's a difference. So maybe you intend to deceive someone, but then you don't actually end up doing it. Let's say I intend, like right now, I'm going to walk over to you and I'm going to lie. That's my intention, is to not lie. I'm going to walk over to you and deceive you. That's my intention. And then I'm thwarted. Not all the things we try or intend to do happen. Did I lie to you? No, I didn't get the opportunity to. So I think we're going to go with just N here. And that, so intending to deceive someone, so have I, that's going to be the right part. And then the person told a lie, say L. So if you tell a lie, then it's required that you intended to deceive someone. So this works pretty well. Sometimes you have both, so, like being liquid H2O and being water. Think about that. Being liquid H2O blank condition or being water. Let's see what I'll do if I do select. No, mouse. All right. Select. There we go. That's what I want. That's what I want. Get out of here. Get out of here. What would go here? Being liquid water. Is that N? Ooh, let me draw. Yes, because being liquid water is a requirement. Sorry, I keep seeing liquid water. Sorry. Being liquid H2O, that's a requirement. If you're going to be water, you have to be liquid H2O, right? If you're going to have water, you're going to have liquid H2O. So it's a requirement. But it's also enough. It's a little dot. It's enough. If you've got liquid H2O, then you're guaranteed to have water. That's just what water is, right? Chemically speaking. And so then you might say, well, then what do I do with my rule here? Well, it turns out that you're still going to follow the rule. So there's an N here. And what is the N? Being liquid H2O. So let's say that is L, and the N goes as the consequent. And then the other one, being water, is going to go over here. And then what we're going to do is we're going to put this in parentheses, and we're going to say an and, because, and we also said that being liquid H2O, which is L, or the thing is liquid H2O, is also S. And S needs to go as the antecedent. So when it's necessary and sufficient, you're going to express it like this. And what you're saying here logically is, again, if we think of this in terms of streets, is that the street goes both ways. You're saying W implies L and L implies W. And so if we think of these as arrows, think of it as a two-way street, we could express this with a double arrow, and we actually can. So when the conditional is a two-way street, when it goes both ways, we can express it like this. And this symbol is acceptable. However, our textbook uses this one, the triple bar or the tri-bar. When something is a necessary and sufficient condition, being water is a necessary and sufficient condition for being liquid H2O. And this, you can write it either way. If it's a two-way street, we could write it like this, and it would mean the same thing. It would mean the same thing. Something being liquid is a necessary and sufficient condition for it being water. So it's a conditional that goes both ways, goes two ways. And so that is a biconditional. Bi meaning two, conditional that goes two different ways. So here's another example of necessary and sufficient with New Year's Eve and December 31st. That's just what New Year's Eve is, December 31st. That's just what water is. It's liquid H2O. And so we can express that with the triple bar or the double arrow. And there's different, just like there's different ways to express a mono or a uniconditional, a regular conditional, like provided or implies, only if. We can also express necessary and sufficient with if and only if. So if it's December 31st, then it's New Year's Eve. If it's New Year's Eve, then it's December 31st, right? This goes both ways. It's December 31st if and only if it's New Year's Eve. So the if part, the if part of this if and only if phrase, that represents the right to left direction, because what follows the if is it's New Year's Eve, and New Year's Eve going, for it to be the condition, the arrow or the horseshoe would have to go that way. So we'd have to start on the right. And the only if, that represents the left to right direction. Someone is a bachelor if and only if the person is an unmarried man. So that phrase, if and only if, we can use the triple bar, the tri-bar, or the double arrow. Triple bar, tri-bar. And we did this liquid H2O water example. We've done a lot. You know, I think we've kind of gone in overtime here for as long for how I want these videos. So I think I gotta stop it here. So we will wrap this up. We have to talk about more about, we talked about unless a little bit, we talked about unless a little bit more. We talk about the main connective or the main operator. We talk about parentheses and brackets. We have to talk about the technical rules of our artificial language, what makes these statements, which we will call formulas, legit, valid, or well-formed. And then we have to do a lot of practice. So we will do that next time. So that's all I have for you, and I will see you next time.